Hey guys, welcome back to my channel and I hope you are all doing extremely well. This is lecture 12 on linked list series. So far I cover 11 lectures and from lecture number 4 we started solving the problems on linked list and I highly recommend you to please do watch from lecture 1 till whatever I'm going to post in future, and I believe that at the end of this series you will be in a situation to solve every linked list problem. And without further delay, let's get into today's lecture. Today we are going to solve one more lead code problem. The problem number is 83. Remove the duplicates from sorted list. That means we will be given one sorted list which consists of duplicate elements, and we need to return the duplicate elements from the sorted list, and again we need to return the sorted list as output, and it should contain only distinct elements. If we carefully observe here 1, 1, 2, 3, 3, and we can clearly observe 1 is duplicated one and 3 is also duplicated one. So we need to remove those two and we need to return 1, 2, 3, and this return list is having now only distinct elements. Okay. Without further delay, let's get into a diagram for a better understanding. And if my list is something this 1, 2, 3, 4, 5. Final. Here we can see there are no duplicate elements. In this case, you just return the head. If it is pointing to this, just return this complete list. So this is a happy flow if there are no duplicate elements. Let's try to see one more case. 1, 1, 2, 3, 3, 3 is next is null. And in this input, we can see there are two duplicate nodes. So how we are going to solve this one? So initially, we are going to point our curve node to the head of the list. That means it is going to point to the 1. So every time what we do means we check whether kernode.next val is equal to kernode.val. So let me write that syntax. If kernode.next.val is equal to kernode.val, if this condition is satisfies, okay, here the condition is satisfying. So if my curve node is pointing to this, so curve node dot next dot val is 1 and that is equal to this. So immediately we are going to connect our curve node to curve node dot next. Okay, that means this link is getting broken. Okay, and we can see now curve node is equals to 1, curve node dot next is equals to 2. Here they both are not equal. At that time, I'm going to change my curve node to point to the curve node dot next. Okay. And again I compare. Is 2 equal to 3? No. Then I will change my curve node to point to the curve node dot next. Is 3 equal to 3? Yes. At that moment, what I am going to do? I am going to point my curve node to the curve node dot next. That means null. So after completing the complete iteration, okay, then what I'm going to have? I'm going to have output as 1, 2, 3, 3 is next is null. That's all. So what are the time and space complexities with this approach? The time complexity is going to be big of n. The space complexity is going to be big of 1 because we are not taking additional linked list or its data structure to solve this problem, and we are iterating only once throughout the list to remove the duplicates. For that it is going to take big of n. So let's try to understand another input. If my input is something like this 1, 1, 1, 1, and next is null. If we carefully observe, so 1 is duplicated one 3 times, and we know our output should look like this, right? We need to remove the 3 ones. Let's try to implement the same logic. Curve node. Is my curve node dot next val, okay, that is equal to curve node? Yes. Then I'm going to point to the this. So my curve node dot next again 1. Is my curve node dot next val is equals to 1? Yes. Then I'm going to point my curve node to the I'm going to do my curve node dot next is curve node is equals to curve node dot next, that is 1 again. Is my curve node dot next equal to curve node? Yes. Then I'm going to point my curve node to the null. And in this case, we can see my curve node dot next is null. Then we need to return the whatever we are at curve node. Okay. So the ultimate goal is every time we need to check the next node value. If next node value is equals to current node value, then we need to point our current node to the current node dot next dot next. That's all we need to do. I hope you understood the logic. Let's get into the coding part. Yeah, here is I am. So what is the base condition? If my head equal to null or head dot next equal to null, that means there is only one node in the list. Just return head, whatever it is. Otherwise, let's take list node equal to list node cur node equal to head. So cur node is pointing to the head. Now the condition is while cur node dot next not equal to null. Till this condition satisfies. Let me minimize this one. Yeah. Till this condition satisfies, the first thing we need to check is if cur node dot next dot val is equal to cur node dot val. That means our current node dot next val is equals to cur node. That means I need to point my current node to the current node dot next dot next. I need to skip my current node dot next, right? So cur node is equal to cur node dot next is equal to cur node dot next dot next. If this is not the case, just I need to move forward. That means cur node is equals to cur node dot next. That's all. At the end, just return your head. Let's try it. The variable name is wrong here. It should be next. Yeah, let's submit it. Yes, it got submitted successfully. So that's all for this problem, and we are going to solve one more variant of this kind of remove duplicates from sorted list problem, and I will posting that in the next lecture. Till then, please do subscribe to my channel and please do learn. Thanks a lot. Bye bye.